Good day, students. Welcome to part 7 of the Algebra I CST review. In this installment, we're going to be going over questions 61 through 70. So let's go ahead and take a look at question number 61. It says, Carter is solving this equation by factoring 10x squared minus 25x plus 10. So which expression could be one of his correct factors? So in this problem, we're basically going to be uh, factoring this quadratic equation. We're not solving it all the way, we're just factoring. Okay, so we have 10x squared minus 25x plus 15. So to factor this, I'm going to be using the x method. So before I do that, I need to break everything down, find the composition of every single term, and then pull out the greatest common factor. All right, so for 10 can be written as 2 times 5 times x, 25 can be written as 5 times 5 times x, and 15 can be written as 3 times 5. Okay, now what can I factor out of all these three terms? You notice that 5 is common, so I can factor out a 5 from all three terms. Okay, so I'll factor that out. We have 5 times, and I'm going to assemble the factors I have remaining, 2x squared minus 5x plus 3 equals 0. All right, now let's shift our attention to the quantity in the parentheses. I'm going to factor that using the x game. So let's make our x. AC goes on top, B goes on the bottom. So AC is, this is A is 2, B is 5, and C is 3. So AC is 6, and B is negative 5. All right, so what two numbers multiply to give you 6 and add to give you negative 5? Negative 2 and negative 3. So let's go ahead and do this. So to do this, I'm going to have 5 times 2x squared minus 2x minus 3x plus 3. Okay, I have a tutorial that basically goes over how to factor trinomials, 3 installment tutorial. You can go to mathserve.com and go over that to help you master the art of factoring. Okay. All right, so I'm going to break it down the center, and then I'm going to factor by grouping. All right, the 5 on the outside, we'll leave that alone. So 5 stays there. And then I'm going to break this down. 2x squared is 2 times x minus 2 times x. And then minus 3 times x plus 3 equals 0. Okay? Now, what can I factor out in this parenthesis? There's a 2 common here. And also there's a 3 common here. Okay? All right, so bring down the 5. And then we have bracket 2. Oh, we can also take out an x, so we can also take out one x from both sides. So 2x, and then you're left with x minus 1. And then you think out this minus, take out a 3, and you're left with x. Anytime you factor out a minus from a plus, the sign, anytime you factor out a minus, the second sign always switches to the opposite. So this becomes minus 3, close that, equals 0. Okay? Now bring down the 5. The two quantities that are identical, this x minus, this is supposed to be 1 over here. This is x minus 1. Or else I'll be wrong, because if I take out 3 from here, I'm left with 1. Okay? So these two quantities are identical, x minus 1 and x minus 1. I factor them out into 1, x minus 1. And I'm left with 2x and negative 3. You put them together, times 2x minus 3. Okay? So these are the factors that we have. So which one matches? X minus 1 is in here, 2x minus 3. Answer to 61 is option D. Okay? All right. All right, let's move on to question 62. It says, what are the solutions for the quadratic equation x squared minus 8x equals 9? So there are two ways you can do this. You can solve this by plugging and chugging. You just plug in the values into this question and see which one is true. And then you can also do this by factoring, okay? And also you can Actually, to be honest with you, there are maybe about 4 ways to do this: factoring, quadratic formula, completing the square, and then you can plug and chug. Graphing is not advisable here. So I'm gonna do the safest one, which quickest, which is just I can just plug in the answers and see which one works. So let's take a look at question 62. This is the equation I'm going to check. X squared minus 8x equals 9. So let's test A. Test A. A is x equals 3. So let's plug it in and see if we have a true statement. Question is 3 squared minus 8 times 3 equals 9. Is it? Is this a true statement? 3 squared is 9. 8 times 3 is 24. Is 9 minus 24 equals 9? Absolutely not. 9 minus 24 is 15. So this is wrong. Now what do? We're going to move on to C. Okay. Why am I moving on to C? Why didn't I check B? Well, if you notice, B has 3, and 3 has already been shown to be a wrong answer. Okay, so we don't need to check B already because it has a wrong answer. If one of them are wrong, then that's inadequate. Okay. All right. So for C, we're going to test x equals 1. Do we have a true statement? So the question is 1 squared minus 8 times 1 equals 9? 1 squared is 1, 8 times 1 is 8. Is 1 minus 8 equals 9? Absolutely not. 1 minus 8 is negative 7, right? And we know negative 7 is not equal to 9. So we can conclude that option C is wrong. Okay? So if option A is wrong and option B and C are wrong, then we know that the correct answer has to be option D. All right? So the answer is D, but how about we make sure? We can't take chances here because we want to pass our CST, right? So we want to test D, x equals negative 1. So let's plug that in and see if we have a true statement. We're going to plug it into this equation. Let me rewrite the equation here so we know what we're doing. X squared minus 8x equals 9. So we're plugging negative 1 is negative 1 squared minus 8 times negative 1 is equal to 9. Negative 1 squared is 1 minus 8 times minus 1 is positive 8. Is it equal to 9? 1 plus 8 is 9 equal to 9? Absolutely. So the first one checks. Does that mean D is correct? No, we have to check both of them, right? Because there are two solutions there. Test x equals 9 also. Is 9 squared minus 8 times 9 equals 9? That's the question. 9 squared is 81. 8 times 9 is 72. 81, so question mark, is this true? 81 minus 72 is 9. Is 9 equal 9? Certainly is, so correct answer is D. All right. Okay, let's take a look at 63. For 63, it says Tom is solving this equation by completing the square, which would be step 3 in the solution. So for 63, we have ax squared plus bx equals negative c. So before I complete the square, I want to make sure that this is x squared so I can read it with ease. So I divide everything by a as it was done here. So divide everything by a. You want x squared standing alone before you complete the square. Okay? So you basically have x squared plus b over a x equals negative c over a. Now to complete the square, you need to add b over uh, b over uh, 2 squared. You want to add b over 2 squared to both sides, right? So in this case, this is a right here, and this is b. So b is b over a, okay? So we want to do b over 2 squared. So this is slightly kind of complicated. So let's work it out. So we have b is b over a. So how do I divide this by 2? How do I divide b over a by 2? Another way of dividing by 2 is simply multiplying by 1/2, right? So I can do b over a divided by 2. So put this over 1. And then this is the same thing as b over a multiplied by the reciprocal of the bottom, right? You drop, change, flip, multiply the top by the reciprocal of the bottom, so b over 1/2. Okay? And that becomes b over 2a. All right? So you don't just do b over 2 square, you don't just do b over 2, you do b over 2 square, right? So we're gonna have to square this. So that means we'll square this also. Okay, so b over 2 square is what completes the square. So we're gonna add that to both sides, and that will be step 3. So we're gonna have x squared plus b over a, x, and then you're gonna add b over 2a square to the left side, and to the right side you're also going to add b over 2a squared. Okay, there you have it. So guess what? The correct answer is option D. All right, now let's move on to question number 64. So for 64, this is what we have. Remember, you can get this document on mathreserve.com/test prep, actually /test-prep, and then you can gain access to these documents. All right, now 64. What are the steps to derive the quadratic formula? Well, if you want to derive the quadratic formula, first of all, here we have the general form ax squared plus bx plus c equals 0. First thing we want to do is we want to move the c over and divide everything by a. So if you subtract c from both sides, you're going to have ax squared plus bx equals negative c. And then you also divide, and I want to get rid of this a here, so I divide everything by a. Down, down, down. And then we are going to end up with step number 1 on there. X squared plus b over ax equals negative c over a. Okay, so number 1 is the first correct answer. So we know that c and d cannot be the answer. Okay, so we can eliminate those. Our answers is going to be b, a, or b. Okay, now what we're going to do next to complete the square is like what we did in question 63. You add b over 2 squared to both sides. So b over 2 squared, as in this case, is going to be b over 2a squared. Okay, so like what we did in the previous problem, we're going to add b over 2a squared to the left side, and then to the right side, same story. What is this? It's supposed to be a. Sorry about that. And then we also add b over 2a squared here too. Okay. All right. So which one matches with this step? This is supposed to be step number 2. So this is IV for step number 2. So the sequence is as follows. You first of all do I, and then you do IV. That's step number 2. Which sequence follows that out of A or B? Sequence A is the correct one. So option A is our answer for this problem. Okay, so there you have it. So let me just finish up the completing the square process here to derive the quadratic formula. So what you do here if you want to finish this off is you root the first and the last term, bring down the middle sign, and that's going to yield x plus b over 2a squared. And then when you find the LCD here and combine these two together, you're going to have b squared minus 4ac. I'm skipping all the steps because this question is not asking for this. I'm just showing you how it works. Okay, and then when you take the square root of both sides and you subtract negative b over 2 squared, you're going to have x equals b plus or minus, actually negative b plus or minus the square root of b squared minus 4ac all over 2a. So the sequence of steps are I, IV, I, and the last step is going to be I. 1, 2, 3. Okay, they kind of didn't combine it, but you see the drill here. All right, so there you have it. Okay, let's move along to question 65. It says, which is the solution to the equation? Now, the question is, can we use factorization to solve this problem, question 65? The answer is clearly no, because if you look at the options, we have radicals there. Anytime you have radicals in your solution, that's an indication that it's going to be prime. You can't factor it, okay? So if we can't factor it, we can either use completing the square or quadratic formula. Quadratic formula is the easiest to use, so why don't we go ahead and use that, all right? So you need to know your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. If you forget, you can always learn the song, and that can help you remember, all right? So a is 2, b is negative 1. Remember, if there isn't any number, you put a 1. And then c is negative 4, all right? So let's plug all that into the quadratic formula. So you're going to have x equals negative 1 plus or minus the square root of b squared. It's negative 1 squared minus 4ac. And then the whole thing divided by 2a. 2 times 2. All right. And then let's simplify this. We're going to have minus 1 times minus 1 is 1, plus or minus the square root of 1 squared is 1. 4 times 4 is 16 times 2 is 32. Minus times minus is plus. It's 32 over 4. Okay? So now that becomes 1 plus or minus 1 plus 32 is 33 over 4. Now we can split it, actually you can split them up. So we're going to have 1 minus the square root of 33 over 4, or 1 plus the square root of 33 over 4. So which of these basically matches one of our options? These are two results. So you can see that option number letter C is our correct answer here because it matches. Okay? Alright, so correct answer for 65 is C. Alright, let's move on to question 66. It says, which statement best explains why there is no real solution to the quadratic equation 2x squared plus x plus 7 equals 0? Well, if a solution isn't real, then it's imaginary, right? So what causes a solution to be imaginary is whenever you're taking the square root of a negative, right? So if you remember definition of an imaginary number, you take the square root of negative 1, you get I, right? So the square root of any negative number, you're going to have an I connected to it. So anything that results in the negative radicand, you're going to have an imaginary answer, an answer that's not real, okay? So how do we know when it's that the answer is going to be imaginary? What you do is you write down the quadratic formula, and you're going to focus on one special part of the quadratic formula. So what is that special part? If you look at this quadratic formula I'm writing here, the part in green, that's the special part. It's called the discriminant, okay? So the discriminant tells you the nature of the roots, okay? It helps you discriminate the solutions, all right? So if b squared minus 4ac is negative, you're going to have imaginary roots. Imaginary roots, okay? And then if b squared minus 4ac equals 0, you're going to have a double root. And then if b squared minus 4ac is positive, you're going to have real roots. Okay, two distinct real roots. All right, now, so in this case, negative 1 squared minus 4 times 2 times 7, that's the discriminant, right? How do we know? Well, let me show you. 2x squared plus x plus 7 equals 0. The equation for the discriminant is b squared minus 4ac, the radicand of the quadratic formula. In this problem, b is 1, a is 2, c is 7. So we plug all this into this, we're going to have b squared is going to be 1 squared minus 4, a is 2, c is 7. So if this radicand is negative, we're going to have imaginary roots. So our correct answer for 66 is option C, because that is what will give us a negative radicand and consequently an imaginary root. So the answer is option C. The value of the discriminant is negative. All right, so C is our final answer for 66. All right, let's move on to 67. It says, what is the solution set of the quadratic equation? So, let's see. All right, so if it's, it might be factorable. If it's factorable, it will be option A, but if it's not, then it could be B, C, or if we have a negative radicand, it's going to be D. So to be on the safe side, I'm going to go ahead and use the quadratic formula because I have three options here that involve the use of the quadratic formula. So even if this is the answer, it's not a problem. It just means I'm doing excess amount of work, but it's the safest way to go. All right, so let's do this. So I have 8x squared plus 2x plus 1 equals 0. So I'm going to plug it into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So a is 8, b is 2, and c is 1. So I'm going to plug it in. So we're going to have negative 2 plus or minus the square root of b squared, 2 squared minus 4 times 8 times 1, okay, over 2 times 8. All right. Now, let's see. All right, so let's simplify this a little bit further. So we're going to have negative 2 plus or minus the square root of 2 squared is 4. 4 times 8 is 32 times 1 is 32 over 2 times 8 is 16. Simplify further, we're going to have negative 2 plus or minus the square root of 4 minus 32 is 28, negative 28 over 16. We have a situation here. If you notice, there is a negative under the square root. So what does that mean? If you have a negative under the square root, you're going to have an imaginary solution, which is not real. Okay, so because you have a negative radicand, that means we have no real solution to this problem because of that negative under the square root. Okay, so our answer is option letter D. Okay, let's take a look at question 68. It said, what are the solutions to the equation? So this one, it looks like we're going to have to do it all the way. 3x squared plus 3 equals 7x. Now, before ever you want to start using any method, you must place the equation in standard form. So degrees in descending order equal to 0. This is not equal to 0. I need to move this to the left side. So I subtract 7x from both sides. So that's going to yield 3x squared minus 7x plus 3 equals 0. Okay? Now, let's see. You see all the options have radicals in them, so it's going to be prime, all right? We have to use a quadratic formula. So A is 3, B is negative 7, and C is 3. So if I plug it into the quadratic formula, we're going to have negative B, negative negative 7, plus or minus the square root of B squared minus 4AC, and the whole thing divided by 2A. Okay? All right, let's simplify further. We're going to have minus times minus 7 plus or minus the square root of 7 times 7 is 49 minus 3 times 3 is 9 times 3. 9 times 3, actually 9 times 4 is 36 over 6. Okay? All right, so that's going to give us 7 plus or minus the square root of 13 over 6. So if we split up our answers, we're going to have x equals 7. Oh, let's do the negative one first, do the smaller answer first. 7 minus root 13 over 6, and 7 plus root 13 over 6 That's the final result, and the answer is option letter C. Okay? All right, let's move along to 69. Question 69. Um, it says the graph of the equation y equals um, x squared minus 3x minus 4 is shown below. For what value of x is y equals 0? When y is 0, guess what? Whenever y is 0, you're on the x-axis, okay? So when y is 0 on the x-axis, so basically what this question is telling you is what are your x-intercepts. So when y equals 0, we have the x-intercepts. The x-intercepts or roots, okay? Intercepts or roots. All right, so where are the roots? It cuts at -1 and 4. So basically, when y is 0, x equals -1 and x equals 4. All right, so your answer is option C. All right. Okay, let's take a look at question number 70. It says, which best represents a graph y equals -x squared plus 3? So for 70, we have y equals -x squared plus 3. Now, there are two things that we're going to look at here, this translation and this negativity. Anytime you have a minus in front of the quadratic, the graph is going to be sad, okay? Because you know how negative people are always sad. So because of this minus right here, the parabola is going to open downwards, okay? Or it's going to be concave down, okay? Sad face, because you have a negative a. A is negative, okay? So we have it facing down, opening down. So that means our answer is going to be either A or C, because I mean A or B, because C and D are opening up. Those are the happy parabolas. We don't want to use those here because we're dealing with a negative situation. So A or B. So this plus 3, does that shift the parabola up or down? Plus 3 basically means whatever value you get for the x, you have to add 3 to get the y. So what's that going to mean? So this plus 3 basically means that you're going to shift up 3 units. Okay? You shift up 3 units after you reflect downwards. Reflect downwards. And you shift up 3 units. So which one is the right one? Is it shifting down A as indicated in A or B? We can clearly see that the answer is going to be option B, okay? Because we reflect the parabola. Let me show you the original one. So let's say you have a parent parabola like this. You have it like this. So first thing you do is you reflect it down, flip it down, and then you shift it up, and then you have a parabola that's 3 units up, something like this, okay? And that's indicated in option letter B. All right, so that's that. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here so you can get the remaining installments for this review series for CST. Click like if you like this presentation, I appreciate it, and also post a comment to let me know what you think. More clips can be found on mathwebserve.com, including the document I'm working on. Thanks again and have a wonderful day.